We want to now talk about converting back and forth between polar coordinates and rectangular coordinates. So polar coordinates, we've now learned you can describe a point on a graph by r and theta. Rectangular coordinates are x and y. So what we want to discuss now is if you're given a point in polar coordinates, we want to convert it or rewrite it in rectangular coordinates. And likewise, if we're given a point in rectangular coordinates, we want to convert that point and rewrite it in polar coordinates. Now in a few minutes, we'll give you some formulas you can use, but let me just briefly describe how we come up with these formulas, because this is stuff we've really done before. So sometimes it's good not just to sort of use formulas, but to know where they came from. So let's just take a graph here. And I'll just choose a random point like right here. And I'll just start out by labeling this point as x and y, which of course means that let's draw this because, well, actually I'll make it a straight line just for fun. If I think of this point now as a polar coordinate, r is like the radius or the distance from the origin to the point, and of course the angle is theta. But here's something I'm going to do. From the point, I'm going to come straight down to this x-axis, and I'm going to form a right triangle. Now this right triangle, if you think about it, the length of this bottom side of the triangle is going to be x, and the length of this side of the triangle is y. And now, here's what I'm going to do. I'm going to use the Pythagorean formula and our trig definitions of a right triangle to come up with some formulas or equations that will relate r and theta to x and y. So for instance, Pythagorean formula says hypotenuse squared, right, this distance, which I'm going to call r, is the sum of the squares of the legs. Now if I want to solve for r, I could take square root of both sides. Now if you look at this, if I'm given a point with rectangular coordinates where I know x and y, you know what? I can simply plug in the value of x and plug in the value of y, do this calculation, and I will have the r of my polar coordinate. So how about what I would do with the angle theta? Well, let's go back to our trig definitions. Let me just write it here, and then I think you'll see it pretty easily. Trig definitions of a right triangle. Remember, so katoa. So the sine, the angle theta, so opposite, well, the opposite side of this triangle is y, over hypotenuse, which is r. Let's do the same thing for the cosine. So ka adjacent over hypotenuse. So katoa tangent opposite over adjacent. So now here are three equations that relate the angle theta to either x and y and r, or even down here just x and y. Now you're going to see in a minute, I'm going to rewrite especially the sine and cosine. Let's just get the y by itself. So y is r times sine of theta, and x is r times cosine of theta. So now, with all the stuff I've got here, I really have the things I need to start converting back and forth. Let's just do an example. So how about I will take a point in rectangular coordinates. So here's an x and y. And I want to convert it to polar coordinates. So I'll do this one part at a time. I'm going to find the r first, then I'll find the theta. Now here's what you really have to do. If you don't do this, you're probably going to mess up. Anytime you do these problems, just go off to the side. It doesn't have to be anything fancy at all. Go ahead and just plot your point. Because you're going to see later on, especially when we start looking at the angle, you need to visually know where your point is to make sure you don't get confused and make a mistake. So 1, -1 is going to be here. So my point is really in the fourth quadrant. So especially when I'm trying to find my angle, that's going to be important. So how can I find r if I know x and y? Well, look here. It's like a little formula. Matter of fact, I'll just say it now. On your formula sheet, look pretty nice to you, because if you look down here, there's a section that says polar and rectangular coordinates. Look, here's the formula for r. Here's these two formulas here, and then this one for tangent. So a lot of the stuff I've put here is actually on the formula sheet. So that's pretty nice. So anyways, this equation, r equals the square root of x squared plus y squared. So for r's, x is 1, 1 squared, y is -1. 1 plus -1 squared is 1, so 1 plus 1 is 2. So it turns out r is square root of 2. So I've already found the r of my polar coordinate. So now, let's find theta. Now theta is interesting because we've got all these different equations with theta. You know what I'm going to do? And sometimes, I mean, you can use whichever one you want, but sometimes you can choose smartly. Now you're going to see why in a minute, but I'm going to use this equation. Tangent of theta equals y over x. So tangent of theta equals y over x. I plug in my values for y and x. Y is -1, x is 1. What I'm really saying is the tangent of theta equals -1. So knowing my points here, we've done this before. I need to find the angle. Ask myself, what's the angle where the tangent is -1 in this quadrant? Well, the tangent is -1. That has to be where the sine and the cosine are the same. And where does that occur? That occurs right here at 7π/4. Now this is why we need to plot the point, because you know what? The tangent in quadrant 2 is also -1. So if you weren't being careful, someone might have put the answer as 3π/4, but that's obviously not correct. So, not too difficult, hopefully. Let's do a couple more examples. Now this next example is one where actually you just need to use some common sense, and we don't even really have to use the formulas as much. what if we were given this point, 0, 2, and that's to find the polar coordinate. Once again, you need to graph the point. So x0, y is 2 is right here. If I'm trying to find the r and the theta for polar coordinate, I don't need to use all these formulas because it's right here on the y-axis. Obviously r is 2, and what's this angle? Oh, sorry. I said 2, but I wrote r. R is 2, and the angle is pi over 2. So that one, I don't even need to use a formula. So sometimes, especially if you graph the point, it's just common sense. Let's do one more where maybe we have to use the formulas. This one looks a little messier, but we'll see how it turns out. How about negative? So here's a point in rectangular coordinates, and I want to know what is it going to be in polar coordinates. Once again, doesn't have to be anything fancy, it could even be sort of small. If both x and y are negative, where does that occur? That's down here somewhere in quadrant 3. So as a polar coordinate, this is going to be my r, and this will probably be my theta. The r is always very straightforward. It's just plug it into the formula. We know r is x squared plus y squared, square root of all that. So negative square root of 3 over 2, that whole thing squared, plus y squared, negative 1/2 squared. So when you square this, when you square square 3, you get 3. When you square 2, you get 4. So this becomes 3/4. When you square this, you get 1 over 4. So 3/4 plus 1/4 is 4 over 4, which is 1. Square root of 1 is just 1. Now let's find the angle. What do we want to do for the angle? You know what I'm going to do? Because I have a choice here. I can do something with the sine, the cosine, and you know sine involves y, cosine involves the x, tangent is, you know what, wow, I messed up when I wrote this down. Should be y over x. I did it correctly here. Oh, sorry. That was from a previous lesson. Here was what I did. So I did it correctly. Yeah, y over x. Sorry about that. So y's, x's, and r's. You know what I'm going to do? Because up here, I'm going to choose to use something with y in it because you know what? It's negative 1/2. If I can avoid this square root, I'm going to. And I think what might be easiest if I go ahead and do the sine. So let's do this one down here. Y equals r sine theta. So y is negative 1/2, r is 1. So what I'm really saying is sine of theta is negative 1/2. That's like a special angle. So it's saying, let's go here in the third quadrant. What's the angle where the sine is negative 1/2? Well, you may know it, or if you want to use a unit circle, right here, this is where the sine is negative 1/2, 7 pi over 6. So going from rectangular coordinates to polar coordinates, not that difficult. The R is very straightforward. To find the angle, you have some choices. Try and be smart, and that'll make it easier on you. Now let's go the other way. Let's go from polar coordinates to rectangular. And this is even easier. This is really the easier one to do. So for instance, here is a point in polar coordinate form. R is 6, theta is 5 pi over 6, and we want to know what is this rectangular coordinate. I'm going to do a rough sketch of this. 5 pi over 6 is over here in the second quadrant, and a 6, so let's just say it's maybe out here somewhere. Definitely second quadrant. These are really easy. I'm going to go back and use, these are the two formulas. Y equals r sine theta, x equals r cosine theta. That's all you need, because I'm trying to find x and y. So x equals r cosine of theta. R is 6. Cosine of theta is cosine of 5 pi over 6. This is a special angle. Cosine of 5 pi over 6, I know, is negative square root of 3 over 2. Six over 2 is 3. This ends up being negative 3 square root of 3. For the y, it's r sine theta. Very straightforward. R is 6. Sine of 5 pi over 6. Sine of 5 pi over 6 is 1/2. Y is 3. 6, 5 pi over 6 in polar coordinates is negative 3 square root of 3 and 3. So this is really to go from polar coordinates to rectangular. Just use these two equations. That's all there is to it. Of all this stuff, going from rectangular to polar, the R is straightforward. The only tricky thing is finding the angle. Of all this stuff, that's the one that can be tricky. Let's do a couple more of these real quick. So here's one. Here's another common sense one. What if we have a polar coordinate of 3 pi over 2? Once again, plot the point. Pi over 2 is straight up, say 3 is right here. Common sense, what's the x and the y? X would be 0, y would be 3. Don't even have to use the formulas. Let's just do one more where we do have to use the formulas, although it's still very straightforward. How about negative 5, negative pi over 6? Let's plot it. So, all right, polar coordinates, so tricky. You always do the angle first. Negative pi over 6 is going to be, however, because it's negative 5, it flips over here. So it's going to be somewhere there in the second quadrant. X, r cosine of theta. negative 5 cosine of negative pi over 6. Cosine of this down here, cosine of negative pi over 6 is square root of 3 over 2. I've got the unit circle memorized if you need to look at it. It's right here. Negative 5 square root of 3 over 2. And that's what we would expect, because we expect the cosine to be negative. So x is going to be negative. Y is r times the sine of theta. So once again, minus 5, and then the sine of negative pi over 6. Negative 5. The sine of pi over 6. Once again, negative pi over 6 is right here. The sine is negative 1/2. Now the nice thing about this here is like a sanity check. This makes sure I didn't make any math errors, because the pluses and minuses, everything works out. If you just do the math, you're going to get the correct answers. And then this graph just makes sure, yes, x should be negative and y should be positive. All right, so that's how you go back and forth between polar and rectangular coordinates.